go over and take a tour of the lab, and we should be out of here as soon as we can be. All right. Okay, so probably no one has any questions, do you? Do you have any questions? All right, well, you know, a lot of times in science, all right, in general, you have to take measurements, all right, and for whatever reason, you may have to take a unit of measurement and go to another unit of measurement, all right. So for an example, if you're giving medicine to a child, let's say, a lot of times that's done based on the child's kilogram per body weight. So naturally you would have to know how to convert pounds to kilograms and so forth. Of course, that's a simple example of conversion. So a lot of times you have to go back and forth from different types of units. So let's talk about converting something very simple to start with. And let's take 3 meters and convert that to millimeters. All right. Now there's a couple of ways to do this, and I'm going to teach a mathematical way. Here's why. Because as a scientist, I know what's coming in the future. All right. So there has to be a way, even though some of you guys can just do this in your head right now, there has to be a systematic way to go through the conversion. That's the first thing. Can you see around that thing? You're okay? Okay. So that's what we're going to do. So first thing is you have to ask yourself, how many millimeters are in a meter? Anybody know? 1,000. All right. 1,000 millimeters in a meter. Now, how did he know that? I don't know how he knew that, right? I mean, 5,280 feet in a mile. Someone asked me, well, where do you just come up with that number? Well, I don't know, Mr. Ashley's world geography class. He's talking about the height of some mountain. I don't know where you remember these things from. All right. Now, we'll go over the list as we go through Chapter 2. Some things you will have to have memorized. I mean, this would be an example. Okay, there's a whole table about that. Other things you do not have to have memorized. All right, so we'll go through that one at a time. Okay, so let's set up here 3 meters. Now, a couple of things that we want to review from simple math class is that 3 is the same thing as 3 divided by 1. Are you with me? All right. So really this 3 right here is in a numerator. Okay. Now, we're going to multiply this by 1 meter is the same thing as 1,000 millimeters. Now, why would I put the meter on the bottom? And of course, the idea is to get these units to cancel. Things on the top will cancel with things on the bottom. Now, your book uses a word called dimensional analysis. And all they're talking about is thingies on the top will cancel with thingies on the bottom. All right, and the big word for that is dimensional analysis. Okay, so naturally we're going to take 3 times 1,000 to be 3,000 millimeters. All right, now would that make sense? A millimeter is, you know, like the size of a penny. And of course a meter is about like this. So if you had 3 of these, naturally you could line up a huge amount of pennies along that distance. All right. Now, what have we done? Well, first off, factor the dimensional analysis, units cancel. The second thing is we've multiplied by something called unity. All right, and again, this is a mathematical term. If, let's just say, you take 3 and multiply by 8 divided by 8, what is your answer? 3. See, 8 equals 8. This right here is called unity, or 1, right? Like if you unify, 1, okay? You see, that's all we've done here. Take a look at this equal sign. No one in the room can argue that 1 meter is exactly the same thing as 1,000 millimeters. See, they're equal. So when you convert, you have not changed the distance. All right, if I tell you to walk 3 meters across this room or walk 3,000 millimeters, there's nothing different. All right, so that's the whole premise behind conversions. Are we okay? Okay. Now, I know some of you guys are sitting there shaking your head thinking, oh, Jesus, this is going to go on all semester. Well, maybe. All right. There are people out there, I mean, you know, you've signed up for this class, and the idea is you've never heard the word chemistry before. Okay. So some of you should be bored, and some of you shouldn't be. And as the course goes along, of course, I'm sure there will be things out there you've not heard of. All right. Now, the next way to do this problem, yes, we're going to work it again, all right, is to use scientific notation. So you could take 3 meters, okay. 1 meter is the same thing as how many millimeters reported in scientific notation. So I guess what I'm asking is, what's 1,000 in scientific notation? 10 to the what? Third. All right. 1 times 10 to the 3. Now let's go back for a quick review on this. You see, I do have a point, by the way, so just bear with me. Anytime a number is greater than 1, okay, such as 1,000, 1,000,000, 1,000,000,000, or what have you, the exponent there will be a positive sign. Anytime a number is less than 1, okay, the exponent will be a negative sign. So, see, there is a decimal there, even though it's not written, and it's 1, 2, 3. That's the number 3. And do you guys see that? Okay, so 3 times 3 times 1 times 10 to the 3 is 3,000 millimeters. All right, again, we've gotten the same result. Now, the third way is the way your book works. All right, now generally this book, Hein, is very good. In this particular scenario, though, I personally think they're asinine. Okay, but whatever. From here on out, we're going to work it the book way, because I think it's so important whenever you go home to study that my notes reiterate what's happening here. Page 23 is where you need to be on this one. Now, what the book does is it says that you got 3 meters there. All right. Now, let's do our unit dimensional analysis. We'll put a meter on the bottom and a millimeter on the top. Is there anybody confused of why we did that? All right, we want them to cancel. Okay. Now look at milli and go all the way to the right-hand side of that table. What number do you see there? 10 to the negative third. Okay. So that's 1 times 10 to the negative 3, and there'll be a 1 there. Now let's talk about this for just a moment. See if we got another color here in the drawer, which we don't, so that's okay. There's 2 types of units here. There is something that's called a base unit. And that's all, I hate to use the word always, but in this classroom here, that's given by 1 letter. All right? And then there is something here called a prefix unit. Okay? And that's given by 2 letters. Again, we're talking about in the 1025 classroom. Now in physics and so forth, sometimes you can get different types of abbreviations, all right? But in the 1025 classroom, that's what we've got. The number in the table, okay, so the number in the table always goes with the base unit. All right, that means the number in the table always goes next to the one that has a single letter. Always. You see, it doesn't matter if the single letter's in the bottom or the top. It matters that the number in the table goes with a single letter. All right, now what's happened here is something the math people call the reciprocal rule. And that states as follows. If you have a number in a numerator or a denominator, and all you do is flip them, the only thing that changes is the sign on the exponent. All right? So this is called the reciprocal rule. So go ahead and type it in. Pull out your calculator, and let's type, where is mine? I've got it here. Let's type in 3 divided by 1 times 10 to the 3. And tell me what you got. First, how does this thing work? Okay, we're going to figure it out. So we got to turn that on first. And then, let's turn this thing on. Oh, I hear it. Okay. So, what do you guys get when you type in 3 divided by 1 times 10 to the negative 3? 3,000. millimeters. Is anybody not getting that? I think you're lying to me. Somebody in here is not getting that. All right. You guys getting that? Getting that?